Hello everyone, my name is Roy Jafari and I would like to welcome you to another video. In this video, we are going to learn 3 data transformation techniques, naming binary coding, ranking transformation, and discretization. These 3 data transformation techniques have something in common that can allow us to cover them in one video. Let's look at the slides and find out what that is. Alright, so what all these 3 data transformation techniques have in common is the fact that when we want to switch between numbers and categories, or from categories to numbers, one of these 3 has to be used. If we want to move, as shown here, from categories, we have to use either binary coding or ranking transformation. And when we want to move from numbers to categories, we have to use discretization. So these are the 3 techniques and tools that we have for our migration from numbers to categories and from categories to numbers. So let's start by understanding why would we ever need to transform our categories, our data shown in categorical attribute, in categorical way, into numerical way. And most of the time, the reason for such data transformation is because some algorithms and some tools of data analytics only can work with numbers. And if we want to use those algorithms, we have to find a way to transform our categorical attributes into numerical ones. How about the why from the numbers to categories? There might be 2 reasons for this. The first one is when we have cases that we want to be able to find and see the relationship, using our understanding and our cognitive functions, as in our human cognitive function, we do better with categories than numbers. So in those cases, we might discretize or change our numerical attributes to categorical one to help our understanding, or to help the understanding of the audience of our visualization. Another reason is, if you remember, when we wanted to see the relationship between a categorical attribute and a numerical attribute, we don't have a tool that can show this relationship when the types of attributes are different. And remember, we said one of these attributes has to change to the other one, and the best one is for us to actually transform the numerical one to the categorical one. Then we could use contingency table and heat map to visualize that relationship. So let's look at 2 examples. In this example, on the first one, we have shown the interactions between 3 attributes. The attribute sex, hours per week, how many hours per week individual work, and the income. And you can see the hours per week is a numerical attribute here, and the income and sex are categorical attribute. And although we were able to visualize these relationships, you must admit that comparing this visual that has a numerical attribute to this other one, that we have managed to discretize the attribute of hours per week. Now we can see the relationship or the interaction between these 3 attributes much better. Stop the video and look at these 2 visuals for a little bit and try to see some patterns. You know what I mean. But let's look at one example together. For instance, we can see in the bottom visual that even though there are more men who make more than 50K than female, but also we do see that there are more male that for getting those, for getting better income, higher income, they're also working more, right? So this is a pattern we can easily see in the bottom visual, the one that does not have numerical attributes, but it would be very hard to see that pattern on the top visual. The other example, in this example, we have age is a numerical attribute. We have discretized age using this function, just for us to be able to use a contingency table to see the relationship between race and age, right? So that's another example of why we would switch from numbers to categories. All right, so now let's focus on our move from categories to numbers and learn our techniques. So from categories to numbers, we either have to use binary coding or ranking transformation. But if you remember, we have two types of categorical attributes. We have nominal and ordinal attributes. Are there any differences if our categorical attribute is nominal or ordinal? Let's find out. If our categorical attribute is nominal, the only choice we have is going to be binary coding. If you have a nominal attribute and if you need them to be re-represented with numbers, that's the only choice you have. Of course, you actually can perform ranking transformation, but guess what? Your results are going to be biased and it's a wrong transformation because nominal attributes, you can only transform them with binary coding. So let's see an example here. Here, for instance, we are using the function pd.getDummies, which is a pandas function, to transform this continent attribute of this data frame. And once you do that, you're going to get this, for each of these possibilities of the continent, you're going to get a new binary or Boolean attribute. And now all of these values are pre-represented using 0, 1 binary attributes. So this is example of binary coding. So how about the move from ordinal to numbers? When we have ordinal attributes, we have a choice between ranking transformation or binary coding. In this example, we see if we were to use binary coding, this would how our data set would look like for education level. If we were to use ranking transformation, this is how it would look like. And I have put something else here, attribute construction, which is another more creative way you could use to transform categorical attribute into numerical one. And something I'm not going to talk more about at this point. We're going to have a video in the future that we're going to talk about attribute construction. And we're going to talk about that there. But now let's focus on the choice between binary coding and ranking transformation. And you can see when we have these two choices, there are pros and cons. And the question, how would we choose between these two, is going to be answered by our understanding of what are the pros and cons and how much weight those pros and cons are going to have in any specific situation, right? So what are the pros? What are the pros of binary coding? The pros of binary coding and the advantage of binary coding is the fact that you do not assume any information. You do not bring any information to your data that they do not exist. At the same time, the disadvantage is the fact that you also have to get rid of some of the information. As we do know that there is an ordinal relationship between high school, bachelor, master, and doctorate, but the binary coded attributes fail to include that information. So basically, we have to get rid of that information. And that's the disadvantage. But the advantage was we don't have to assume any new information. But with the ranking transformation, we have assumed some information into the data, right? For instance, we are assuming that high school is 1 unit less than bachelor, and bachelor is 1 unit less than master, and master is 1 unit less than doctorate. So we don't know if there are those 1 unit relationship between these possibilities of education level, right? We don't know that. But at the same time, by using numbers, we were able to retain the ordinal relationship between these ordinal possibilities, or the possibilities of this ordinal attribute. So that's the pros and cons of ranking transformation. All right, so let's switch gear here. Now, how about when we want to move from numbers to categories? And the only method that we have in these situations is discretization. Discretization is simply us putting some cutoff points in our numerical attributes. So for instance, in this example, we've got age as our numerical attributes, and we put these cutoff points and we count the number of data objects in those bins. And by doing that, for instance, this pd.cut function does that for us. And by doing that, we switch our numerical attribute into a categorical one. Now we have 5 categories, right? We've got 5 bins for age. So that's one way we can go about discretization. So I said one way. What are the other ways? So we've got 3 types of discretization. We can do equal width, we can do equal frequency, and we can do ad hoc. What we did just now was equal width, right? This example was equal width. I mean, we have an equal width between these bins, right? This is called equal width discretization. The other, and also this is the function you would use for this in Python. The other one is equal frequency. In equal frequency, what we try to do is not to have an equal width. We will try to find cutoffs that would lead to the same number of data objects or frequency under each bin, right? So it would look like something like this, but how would we come to these? There can be some calculations. You can do this by calculation, but you can also use just this, powerful function qcut from pandas, and you just put the q as 5, and this just does this trick for us. And you can see, even though the frequencies are not actually the same, there might not be a cut that can create actual, equal frequency. That cut may not exist, but what this function finds is the best possible you can find to get to those equal frequencies. And the last one is ad hoc. The ad hoc one is the one that we basically select the cutoff points based on our understanding of the data. We just know that this cutoff is going to be working better. For instance, in this example, the hours per week that we saw an example that we had discretized, we do see a very large spike in the data that is 40 hours per week. Working for 40 hours per week. And we do understand why is that, because in the US, most people work 40 hours a week. And because of that, how about we create this discretization that we've got 40 as one possibility, anything less than 40, 1, and anything larger than 40, another bit, right? So in those situations, we have to use other methods. For instance, here we have used the apply function and the lambda to say if it's if the value is greater than 40, I want this sign. If it's 40, I want this sign. Otherwise, I want the smaller than 40. And when we do that, we get this is neither an equal width or equal frequency, but you must agree this is the best for this specific situation. So it would be best for us to do this discretization ad hoc. So the question we have to answer here: how do we know which one of these to move with or to go with? I have a few suggestions, and there is no best answer to sort of give to this. How do we choose? I would suggest for you, every time you face this question, first draw the histogram of your numerical attributes. Try to find out any information you can find about this specific attribute. Those information might give you some indication what would be the best way to go about this. And lastly, try a few things, right? Do equal frequency, do equal width, try out some ad hoc, And also, you want to pay attention. What is the reason that you're doing, this discretization? For instance, if your reason for discretization is, for helping human audience to connect with the data better, you want to keep with the lowest possible numbers of bins, right? You don't want to still overwhelm your audience. And with all of these in mind, you will come to best possible discretization method that we have seen a few examples here. All right, so one last thing we want to talk about before ending this video is when we do any of these transformation, ranking transformation, binary coding, discretization, are these data massaging or data transformation? Most of the time when we do move from categories to numbers, we do it out of necessity, right? And we do it because our algorithms would not work if we were not able to have those as numbers. But in the cases that we use discretization to move from numbers to categories so our visualizations are more effective, I would argue those cases could be data massaging. All right, until the next video.